So in the next section, we're going to look at the correlation and regression idea. This is also known as the line of best fit if you're talking about algebra. Well, if we're going to put this into our Nspire calculator, and I would strongly suggest that you do, the first thing you want to do is you're going to open a spreadsheet, input the values into that spreadsheet, being sure to name your list like we've done the whole time, and go back to your home screen, open up a calculator screen. You can do this from the table. It's just a lot easier to do it from the calculator screen. It's easier to read sometimes. And then hit the menu button, statistics, stat calculation, and then linear regression. But notice there's two of them. You want the A plus BX. That's the form we use in statistics. You want to make your X list your explanatory variable, and you want to make your Y list your response variable. Remember, these are what you named earlier. And then hit enter. It's going to give you a couple numbers here. It's going to give you your A value. What is your A value? Well, it's basically your y-intercept. Your B value is going to be your rate of change, which we've referred to in algebra as our slope. But we're going to refer to it as rate of change here because we're talking about how y changes in comparison to x. And my R value is going to be my correlation coefficient. Yesterday we talked in the video about the strength of the relationship. This will tell us a lot more. Your correlation coefficient, your R value, will always fall between -1 and +1. It can be inclusive of those two. As we get closer to the extremes, as we get closer to 1 and -1, the relationship becomes stronger. As it gets closer to the middle, as you get closer to an R value of 0, it becomes a weak relationship. And we'll talk more about that during class, but just keep in mind, if I'm looking at something like an R value of let's say 0.89, it's a positive value, we'll say. That's going to be a very strong positive correlation, positive relationship. Residuals. So what are residuals? Well, residuals are what should happen versus what does happen. So what we're going to be able to do is we're going to have an equation, and we'll see that in a little bit, and that's going to be made from these two values here. Because remember, we're following this A plus BX format. We're going to have a y equals mx plus b type equation. Once we have that, we'll be able to plug in the x value, the value of the explanatory variable. Once we plug that in, we do the calculation, it's going to give us what we expect our response variable to be. Your residuals are just simply the difference between the two. If the observed value is higher than the expected value, you're going to have a positive residual. If the observed value is lower than the expected, you're going to have a negative residual. So let's look at an example. We're going to look at the example we looked at for the scatter plots. And what I want you to do now is open your calculator up and go ahead and make a list with oil changes and repairs. Follow the steps we talked about, how to do this on the calculator that are also listed in your packet. And once you do that, follow all the steps to get your linear regression numbers. In this case, our explanatory is the oil changes. Our response is the cost of repairs. And then find the A, the B, and the R value, and we'll discuss what they mean in a second. Pause the video while you do this. So now you've done that, you should have gotten an R value of -0.89. Because we're talking about a negative number here, we know we have a negative relationship. What does a negative relationship mean? It means that as one of the variables increase, the other decreases. So in this particular case, the more oil changes, the less the person pays in repairs, in theory. We also look at this, and it's very, very close to the extremes. It's very close to -1. Since it's very close to the extremes, which is -1 and +1, we have a strong relationship here. So this would indicate a strong negative relationship. So now we talk about our regression equation. Notice that I'm not putting y or x in here. I'm actually putting in values. I'm actually putting in words. So in this case, this would be the number of oil changes over here for x, or my explanatory, and the predicted cost. Notice I'm not saying cost, because we have the costs up here. This is what I predict the cost to be. This is my y-intercept, my a value. What this basically is saying to me is, if I have 0 oil changes, I'm going to end up expecting to pay $666.87 in repairs. Expected, predicted. Then I have my rate of change, which is a negative number, which makes perfect sense. It has to be negative because my relationship's negative. And what does that mean? Well, you think about the way rate of change works. It's your change in y over your change in x. So what this is basically saying is my cost in repairs decreases, because it's negative, by $39.89 for every 1 additional oil change, because we could put that over top of 1, and when I do that, this indicates the change in the y value per 1 change in x value. So in this case, the cost of repairs goes down by about $40 every time I change my oil once, in theory. Well then, how are we going to make predictions? Well, simply this. Take 9 and plug it in here. When you do that, you end up with an expected value, an expected cost of $307.86. So if we look up here, it kind of makes sense, based on all the data, that if I had 9 oil changes, this is how much I would be predicted the cost. Not how much it's going to cost, how much I would expect to pay. Well, now we come over to this 28. We talked a little bit yesterday about what this is. And the fact is, 28, if I plug it in here, it's going to give me a negative number. It's going to give me negative 450 and change. Well, the problem is, look at my oil changes. The highest number I have here is 18. We talked yesterday. This is what we refer to as extrapolation. And since it's extrapolation, I can't do this. I can't plug in 28. Because it's outside of my domain, it will not give me a relevant answer. We'll focus more on this in class. This is regression and correlation.